What does it mean to say two quantities are proportional? When we say that two quantities are proportional, we mean that their ratio stays constant, even when the particular quantities change. So let me give you one commonly encountered example of proportional quantities. So suppose Jim works for an hourly wage. One week he works 7 hours and earns $91, and another week he works 5 hours and earns $65. His earnings are proportional to the hours that he worked. How do we set up the proportion related to this problem? Well, when I'm setting up a proportion from a paragraph, I start with an equals sign and two fraction bars. And then, well, I want the ratio of my two quantities to stay constant, even as the quantities change. So I'm always going to set up the same ratios. Let's say I'm going to set up earnings to hours. That means the first entry in each ratio will be earnings, and the second will be hours. The ratio stays constant as the quantities change. When did the quantities change? They changed from week 1 to week 2. So I'm going to say my first ratio is about week 1, and my second ratio is about week 2. All right, but now it's really easy to see which number goes where, right? Here I'm going to want my earnings in week 1. That'll be $91. Here I'm going to want my earnings in week 2. That'll be $65. Here I'm going to want my hours worked in week 1. That'll be 7 hours. And here I'm going to want my hours worked in week 2. That'll be 5 hours. The last thing I want to call your attention to here before we check that this proportion is actually true is the units. The units in my cross products have to be the same so that we can compare them. What do we have here? We have dollars times hours, and we have hours times dollars. So we're good. All right, let's look at the cross products and confirm that these are in fact proportional. 91 times 5. I want to ask, is it equal to 7 times 65? All right, well, 91 times 5. 5 times 1 is 5. 5 times 9 is 45. So over here I get 455. 65 times 7. 7 times 5 is 35. 7 times 6 is 42. 3, 4, 5. And those are equal. So that actually worked. All right, I'm going to give you one of these to try. Write down the proportion described in the paragraph, and then confirm that it's true. Suppose that a certain poster comes in two sizes, a large and a small. The large poster is 34 inches wide and 44 inches tall. The small poster is 17 inches wide and 22 inches tall. Confirm that the width and height are proportional. Pause the video and try this now. All right, so I think that the ratios I'm going to set up are width to height. So that means I'm going to have width as my first quantity and height as my second. And then I have to pick one ratio to write first. I think I'm going to write the ratio in the large poster and then the ratio in the small poster. And now it's very easy to read off all of the numbers. The width of the large poster is 34 inches. The height of the large poster is 44 inches. The width of the small poster is 17 inches. And the height of the small poster is 22 inches. Noticing that the units in the cross products are both inches times inches, I can ignore them. So 34 times 22, that's the first cross product. Is it equal to 44 times 17? Well, let's actually do this multiplication. 34 times 22, 2 times 4 is 8, 2 times 3 is 6, 2 times 4 is 8, 2 times 3 is 6, 8, 14, 7, 748. 44 times 17, I'm going to choose to write 44 on the bottom, because then I only have to multiply by 4. 4 times 7 is 28. 4 times 1 is 4, plus 2 is 6. 4 times 7 is 28. 4 times 1 is 1, plus 2 is 6. 8, 14, 7, yes. And so the width and height are proportional.